Hey guys, Professor and we're back for another video. Inside this video, we're going to be wrapping up the chemistry unit for grade 10. So, in this video, we're going to talk about acids and bases. And rather than talking about our last video, which we talked about the pH scale and how to identify them, we're going to be talking more about the theory behind the acids and bases. So, as we learned in our last couple of videos, we know that acids have more hydrogen ions, so they have hydrogen ions greater than a hydroxide. Which we have negative. So we have a OH negative. We know that it has to be aqueous, and we know that it has to have a pH below 7. So pH between 0 to 6, and that's going to be in whole numbers, not in decimals. So in this video, what we're going to be learning about is the two different types of acids, the oxoacids and the binary acids. So let's talk about the binary acids first. Let's just write it down. So, as we learned in our reaction video about how synthesis reactions were the most common reactions you see in your everyday life, this is similar to how binary acids are in the acid family. So, you'll see most of these acids in your common day life, even in household supplies, you'll see them. So something like HCl is a binary acid because we know that it only has one nonmetal and then one hydrogen, and that's a characteristic of a binary acid. It's one or hydrogen um, with a nonmetal, and that's going to be character. It doesn't matter how many hydrogens are. It doesn't matter how many nonmetals are, as long as there's just only one nonmetal, one hydrogen present, like the actual elements, not the number of amount of there is of them, but just the actual elements. If there's only one hydrogen element, one nonmetal element, and we don't have any third element, then it's going to be a binary acid. So if we have something like HCl, or we have something like HI, or we have something like H2SC, these are all going to be your common day binary acids. So let's just talk about how the acid forms. Well, pretty much all these acids are going to form from a gaseous compound. So if we take all of these, let's just take HCl for example. Well, we know that this is going to be hydrogen chloride, so let's just write that down. And we know that it's going to be hydrogen chloride, so we also have to write down what it's going to react with to cause it to become an acid. So we know that acids have to become aqueous solutions, and the easiest way to for anything to become aqueous is to react with water. So if we have water plus here, this is going to form into HCl again. Remember, water is just H2O, so we have H2O, and we're just going to have HCl form. So let's just get rid of that too. We're going to have HCl form here, but this time what we're going to do is we have HCl but with an aqueous. And rather than calling it hydrogen chloride, we're going to be calling it hydrochloric acid. And what we're doing with the name is that we're pretty much getting rid of the GEN in hydrogen and having just a hydrogen. We're getting rid of this IDE ending on chloride, and we're just going to put a IC. So we have IC, and then we have hydro. And that's how we're going to write the name down. So we just have hydrochloric, and then we're going to be writing acid. So this is hydrochloric acid. And it's going to be similar with all these. So we have hydrogen iodide, and then we have hydrogen selenide, and they're going to become hydroiodic acid, and we have then hydroselenic acid. And it's going to have the same process where pretty much the compound's going to react with water, and it's going to create an aqueous solution for the actual compound. So the gaseous compound is now going to become an aqueous solution. When it becomes an aqueous solution, it'll become an acid. Now, and acids and bases have different categorizations. They can either be weak acids or they can be common or strong acids. And the way we pretty much determine them, it's quite hard to explain without knowing a bit further chemistry, but pretty much the process is it's a process called dissociation, and what pretty much it is just that molecules are just going to be separating, and when they're separating, um, it's pretty much what it's going to happen is that it's just going to be separating into proper molecules. And if something's being left out, for example, then it's going to be a weak acid. So, examples of strong acids are anything where something has been completely ionized. So, those strong acids could be, um, for example, like if we take a weak acid, for example, and we take hydrofluoric acid, that would be a weak acid. But if we take something like hydrobromic acid, for example, that will be a strong acid because what's going to be happening with hydrobromic acid, for example, is that we have H3R, so we have hydrogen bromide, and when it's going to react with water, this entire thing is going to be ionized. So nothing's going to be partially ionized; it's going to be completely ionized. And when it's completely ionized, dissociation takes part fully. And when dissociation takes part fully, it becomes a strong acid because nothing's really being left out. For example, so this will be HBr. But in your general chemistry courses, you would not have to worry about this. But if you do take further chemistry, dissociation will be one of the things you will learn. But that's just some extra knowledge you guys might want to have. You guys can look into it further, but it's just an extra knowledge just to know that why some things are called strong and some things are called weak. So moving away from binary acids, let's talk about oxoacids. So what pretty much oxoacids are, they're similar to molecular compounds as how binary acids were similar to ionics. So what oxoacids are, is pretty much just going to be hydrogen uh, with a non-metal oxide. So we have non-metal and then we have oxygen. And pretty much what's going to be happening here is that the similar thing um, as with the binary acids, it's going to be creating a water. It's going to be creating a water reaction that is going to be creating the oxoacid. So initially, what we're going to have is that we're not going to have the actual compound react with itself with water, and this is why we don't have hydrogen in the final display in the final actual answer. So what we'll have in a oxoacid is that when we have hydrogen, oxygen, and we have a non-metal, we have this oxoacid, we have this non-metal oxide. That's one part of the oxoacid, and then we have a second part which is hydrogen. You have to remember that these are two separate things. These are not combined. These are simply what's inside the oxoacid. Do not count the non-metal oxide and the hydrogen as one piece, because remember, there's different pieces inside of these reactions. Inside this oxoacid, there's two different pieces. There's the hydrogen and the non-metal and the oxide. So that's the two different pieces. Do not confuse them and do not take them as one entire piece of the reaction. So if we take something like H2SO4, for example, this H2SO4 is pretty much, what is it? Well, we know that it's all it is. It's just hydrogen sulfate. But what it's going to pretty much be is it's not simply just hydrogen sulfate. If we have a aqueous here, what's going to be it's sulfuric acid. But to get to sulfuric acid, there's actually a process which needs to be taken. So let's write down the compound itself. Well, before H2 and SO4 reacting, what do we have? Well, let's look at the actual reaction itself. So we have water. So we have take water for example. We have H2O. So if we get rid of H2O from here, so we get rid of the H2, we get rid of the H2, and we get rid of one oxygen, we get rid of one oxygen. We have three here. So what we have before the water reacts with the SO, before hydrogen sulfate forms, is that we're going to have SO3 actually. So this is going to be the actual compound which is being formed into the actual oxoacid. So remember, just as I said before, do not take the hydrogen and non-metal acid as one piece. This is the most important part of the oxoacids, and this is where most people mess up and not understanding it. So if we take H2SO4 and we get rid of the H2O, we're left with SO3. And let's just write the state of matter. Well, we know SO3 is a gas because just because of the way it's formed. So we have sulfur, and then we have oxygen. So what we have is that we have sulfur trioxide, we have gas, and then what we're going to have is that we're going to have water react with it. So we have H2O. And what pretty much is this going to be? It's going to be similar to what we learned in our last video, synthesis reactions. So synthesis reactions are going to take place, and we're going to add H2 here. So we have H2, and we're just going to add the water. So we have SO4 because we have one oxygen left. And pretty much now what's going to become is that the liquid in the gas form, and then we're going to have an aqueous solution. And this aqueous solution is your sulfuric acid. Sulfuric acid. And how you get a sulfuric acid is that, remember, we took the SO3 initially, and when we have the SO3 initially, we don't have the hydrogen or anything to deal with the hydrogen because, that's not the original root compound. But we do have is that we have this original part, so, well, we have sulfur, so let's just take sulfur as the main root of this compound. So we have sulfur, and what we're pretty much going to do is that we're going to get rid of this UR part, and then we're pretty much going to add we're actually going to add it again when we're doing it again. Just this UR is just demonstration, but you can completely skip this part. But we're pretty much going to get rid of this UR part. And then we're going to add the last letters of the actual compound again, so we have the UR again, and we're going to add IC this time. When we do this IC, this is going to create the sulfuric acid. So we have no hydrogen present because, again, we know that it was not in the original compound, and we have the original root element of the original compound. What we're pretty much going to do, we're going to add the IC. That's the main part of this of pretty much oxoacids. You don't really need to get rid of the UR. That was simply just a demonstration of how what's going to be pretty much happening. But yeah, you're just going to have the IC, and we're going to have acid. And just remember that it is an aqueous solution. So yeah. So let's just get rid of this quickly. So our final thing we're going to be talking about is bases. And bases are quite interesting. I would say they're much harder to understand than acids at first, but in the long term, it's a much more beneficial knowledge to understand in chemistry of bases compared to acids. So pretty much what bases are is that we have oxygen, we have hydrogen. So let's write down hydrogen really quickly, and then we have then we can have any third. Oxyacid. So pretty much, pretty much what we have is that we have the oxygen, and then we have metal, and then we pretty much just have a metal forming with the oxygen and hydrogen. So we have this non-metal. So this is why when you look at bases, so we look at something like NOH, and going back to the strong and weak bases, NaOH would be considered a very strong base because the ionization, when it takes place, it completely ionizes the reaction. So NaOH would be considered a strong base. So this would be a base, and pretty much what the reactions that take place is that we have the metal oxide. So similar to how we have the non-metal oxide in the oxoacid, we have the metal oxide inside the base, so we have metal oxide. And then pretty much we have just water, and that's going to create the base. Plus water, and it's going to create base. And bases are also aqueous. So if we take something like let's take something like lithium and oxygen, for example. So we have the ionic compound of LiO2. So we have Li, and then we know that oxygen has two ions. So we have two here, and then we have one oxygen there. So then pretty much what we're going to have is we have LiO2, and then we have plus H2O. H2O. And what we're going to end up with is LiOH. OH, aqueous. Similar to what we have with sodium, is that we have Na plus, right, this, yeah. So we have Na2OH, or Na2O, plus H2O, and then this will be NaOH. So those are some examples of some bases, and pretty much what's going to be happening inside these bases is that we're pretty much just going to get the non-metal oxide to react with water, and then that's just going to pretty much just create the metallic base. In this case, it'll be lithium hydroxide and sodium hydroxide, and pretty much just the way we write these down is that we're going to take this first element of the oxide. So the non-metal oxide will always have the metal and then the oxygen. So we're going to take this metal, and we're going to take this metal as it is. So we have lithium. This is right. Let's go down a bit. So we have lithium as a whole. We're not going to change this lithium, but we're just going to add it completely as it is. And when we have lithium completely as it is, all we're going to add is we're going to have a hydroxide. And this hydroxide is simply indicating that we have a base present. Because as we know, a base will have more hydroxide ions than hydrogen ions. So that's going to be the general thing for bases, is that simply just a metal oxide is reacting with the water and is going to create the metallic base. In this case, it will be sodium hydroxide and lithium hydroxide. And just remember, it's aqueous as well. So that's going to be the general term for the acids and bases. Hopefully in this video I've covered much more than I did in my pH one, where now you guys are able to understand why certain things have oxoacids, why certain things have binary acids, what different types of acids there are, and how the bases are pretty much formed. And some of you may even learned about dissociation inside the reactions itself and complete ionization. If you guys have any questions about this bases or acids, because I know this is a pretty difficult concept to learn at first. So if you guys have any questions, please leave them in the link below, and I'll try to answer them with as much detail as possible, so you guys are able to understand them. And with that note, and more Professor out.